Hello, Charity. Thank you for talking with us and welcome. Before starting, if I may, I'll say some things about me so you have a bit of context on today's discussion. So, reading a bit about you, I found that we have some similar things that in our past. I'm like a very small clone of you, really. A more imperfect one. So I've started my career as both as a developer, then I went a bit more to operations, and I really genuinely feel you because I always end up doing operations and databases, and it's not that I love to do that. I always end up doing it. And then I switched more to what is considered to be DevOps and a DevOps engineer. Now I'm continuously arguing that it's not a role, it's a culture. I'm
There you
continuously
go.
arguing that. And now I'm a CTO, and similar to you, I'm more of a uh, doing podcasts and creating a community and a bit far further from the technical side, which I love, but still doing that and very, very thankful to where I'm now.
Yeah.
So, if you can tell us a bit about your history and your journey up now.
Well, much like you, I guess, I've been an engineer. I've always gravitated towards the operations side of the house because well, I like the intensity of it, I guess. Um, Started Honeycomb about 6.5 years ago, and was CEO for the first 3.5 years. I've been CTO ever since. Switched places with my co-founder Christine, and I miss doing technical work too.
I get it totally. So, how does your day look like right now as a CTO? And then I'll share how it looks for me, and we'll see if we have some similarities.
Sure. Well, gosh, every day is different. When you're an engineer, I think there's a lot more regularity to your days because you're planning to build things. You're executing on things. When you're, I feel like when you're an engineer, your job is to really set aside time to go deep on things and build things and understand things. When you're a manager, your job is to be interruptible and to spend, a lot of time responding to things, reacting to things, um, and you know, uh, I spend a lot of time doing podcasts. I spend a lot of time writing. I've spent a lot of time for the past 3 years dealing with the book, which just got published, and now I find that I'm having a hard time motivating myself to actually do any writing. Whereas before I was fine with it, and now I'm just like, I don't feel like I could do any more writing. um, but it's kind of whatever the company needs from me on a given day, whether that's recruiting or interviewing or working on internal culture and hiring practices and so forth, or if it's more external, like evangelism for the company or for observability or whatever. So how does that match up with you?
Exactly. I mean, I liked the whatever's needed. I totally understand that. So whatever's needed, both from the technical side and even the customer success and talking with clients and being involved a bit in the product and even
Yeah.
with engineering and then talking and doing podcasts. But
Yeah.
I also love doing this because I get to talk a lot with wonderful people.
Are you an extrovert?
Not sure. I think I am. I love talking, so that's a good
Do
sign,
you get a
right?
lot of energy out of being with people, or do you get a lot of energy out of being alone?
Oh no, just being with people. I mean, I wouldn't.
Yeah.
I can't. I can't be alone.
Really?
I couldn't. No, no,
Yeah,
no.
I'm the opposite. I am very much an introvert, and it takes a lot of energy out of me. So I've learned to be very careful with how I shepherd my energy and giving myself, I can't do meetings back to back, one after the other. I have to like do have half an hour between them so that I can kind of recharge, so that I have enough energy to give again.
Mm-hmm. So let's talk a bit about your book because you've published Observability Engineering, and I have to say that I went through it. I haven't read all of it. I read some, half and some of it, and first I want to congratulate you because it's
Oh, thank
really
you.
wonderful written. I mean, I think it's the most beautiful written technical book that I've ever read.
Oh, thank you.
Yes, and I loved how the book started. I think it's a bit philosophical at the start and talks of
Yeah.
a lot of concepts. It takes observability. It takes it takes the sense of what observability is viewed in the mainstream media and
Yeah.
how people want to sell observability, which and sometimes they say sell
It,
monitoring really.
it was a little bit of a risk, I think, and you can see like our reviews on Amazon. Some people don't make it out of that first section. They're like, "This isn't a technical book. Why are you just telling us all about this stuff?" And I get that. A lot of people look to these books for copy pastable, snippets of things that they can just look, that they can just copy over to their, whatever they're doing. Like so a lot of people are like, I thought you were going to teach me how to use Prometheus with this, and I'm just like, ah. If you do read farther on in the book, you do get to some very deeply technical stuff. Like we talk about, the internals of storage engines and how you can build one for observability. We talk about instrumenting your code with OpenTelemetry. But because in my view there's been such a shift in the way that we in what our systems look like. It used to be you had the app, the database, the web tier, just like the 3-tier model, and monitoring worked really well for that. And I felt like people needed to understand why that isn't working for them, because a lot of people have had this experience where they're using their tools, they're managing their systems, and it feels like you just hit a wall, and suddenly what worked for you stops working for you, and it's really kind of terrifying. And and you're feeling kind of like, what's wrong? Is it me? Is it, and like the point is that no, things are changing. Like systems are changing, our users' expectations are changing, our need to like be able to understand at a very fine grained level, because it's not about understand. It's not about operating. We don't operate systems anymore, right? We build them. And it used to be that if you're an operator, like you never really looked inside the black box, right? You treated the application as like this black box that somebody else would bother with, and this was like the dividing line, right? You either built it and understood it, or you ran it and understood that. And that just doesn't work anymore. You can't write the software without understanding how to understand it, how to use it, and you can't run the software without understanding how to write it and how to use it. And so like it's like the tools that we used to use for debugging and understanding software were like debuggers and things that you used offline. And because so much of your code is not your code anymore, it's your code running in the environment that it's running in, and you being used by the users who are using it, and that intersection, that area of overlap, right? That's all that matters. And so, the tools that were offline aren't enough anymore, and the tools that just like sat outside of your code aren't enough anymore. And so I think we did spend a lot, maybe too much time, like just trying to discuss that. But the thing is that like we wanted people to understand some of these things from first principles, because there's a lot of snake oil out there. There are a lot of people who are just trying to sell you a load of crap for a lot of money, and they're using the same exact words. And so if you don't understand the concepts, you're going to get taken for a ride.
Yeah, yeah. So um, you made 3 points that remain with me that I really adored what you said. So the first one is why does the transition from the initial monitoring has to do with how we do need to transition to observability, and the point was with monolithic applications or structures that, like you said, a web server, a database, a cache, and that's it. You had intuition when you were debugging things. You could use your intuition. So monitoring meant you think of some metrics, and you think of metrics based on the problems that you've seen before happen in such environments. But now we've shifted to microservices, and you have thousands of them, and it's not intuitive anymore. There are a combination of states that you haven't seen before, that you have no idea to how to start debugging, which means that in the first place you don't know what metric you're looking for. And that's one of the shifts that Banishal is also trying to do with environments as a service. Now, when developing a monolith, People can do it. Developers can make their code up to date even locally. But when there are hundreds of services and teams of tens of developers working, how do you do that? It's not intuitive anymore. So that was the first point, that and this is something that I see that even though technology is shifting and it's changing incredibly rapid, the way that developers work and some of the tools are not changing enough to support development flows. And the second point, which is related to the first, is that monitoring and metrics was considered something that sysadmins were doing, right, for seeing how the production looks like. But now, with the DevOps culture and shifting left, developers care about how their application reacts, about the performance, which means that observability is not for the sysadmin, it's not for that operations engineer, it's for all the engineering team. And I think that's a great point that the book is making on why observability is so important in the development flow.
Yeah, exactly. Yeah, yeah, couldn't say it better myself.
Perfect. So let's see about Honeycomb. So what are you excited about today and in the future? And also tell us a bit about Honeycomb.
Well, Honeycomb is, a tool that was very much purpose built for observability from the ground up. And I think if you accept the definition that observability is about, the definition of observability from a systems engineering perspective is that, observability is the mathematical dual of controllability. And it refers to how well can you understand the insides of your system just by looking at it from the outside. How much can you understand any internal state that your system can get into just by, asking questions and observing it and interrogating it from the outside. And so I think if you accept that definition, then there are things that precede, like a technical definition that precedes from that about observability, which is like, you know, well, you mentioned metrics, and how you have to like predict them in advance. You have to decide up front, I want to capture this specific metric, right? And a metric, there are like big M metrics and little m metrics. Big M metrics is just like, little m metrics are just like generically like any numbers that have to do with understanding your systems. But then there's a metric, as it just means it's a number with some tags appended. And so that number that you capture might be the number of users from Germany who are on iOS devices using the German language pack, running build ID 5, and using this particular like device ID, right? Now, like device ID obviously is a dimension that has very high cardinality, meaning a very high number of unique IDs. You cannot possibly predict all of the device IDs that are going to connect to your system, right? So you can't have observability just by using metrics, because you have to decide up front what every single one of those numbers is going to be. Because the source of truth for monitoring is the metric, the big M metric. The source of truth for observability has to be these arbitrarily wide structured data blobs, where every single one of those, which means you can have as many key value pairs as you want in that blob, each one of which, represents something about the environment. But crucially, they don't have to be as specific as metrics. They can be key value pairs that can be very high cardinality. So obviously, if you want to have observability, you need to be able to support high cardinality, high dimensionality, which means the width of that row. Because anytime you have schemas or some sort of fixed, like this is the definition, this is the data type that you need to submit, here are the data types, then you don't have observability, because you can't predict all of the types of dimensions that you're going to need up front, right? And so high cardinality, high dimensionality. It also requires an interface that's very much explorable, one that doesn't just lock you into like dashboards. Creating dashboards, is a way of saying, okay, these are the numbers I'm going to have to care about in the future, which is, again, very anathema to observability. They're great for monitoring. Dashboards are great for lots of things, but they're not observability. They don't help you understand any random state that your system get into just by looking at it from the outside. So Honeycomb is, I think, the first, I would say, we and Lightstep are really still the only two companies out there that actually do observability. You've got a lot of companies out there that are repurposing their monitoring project, their like monitoring products and their logging products and their tracing products to call them observability, but they aren't because they're the same old tools branded with observability. Honeycomb, as anyone who's been listening to me for ages, well, no, it's not like that, right? You can set these arbitrarily wide blobs in there, and then you can slice and dice. You can ask as many new questions about them as you want. You can take those blobs. You can say, well, okay, show me that same, but show me now for companies that are coming for users that are coming from the Netherlands, or break down by all of the unique device types that you've ever gotten, or break down by all the unique device IDs that you've ever gotten, and then show me which of them are sending the most requests, or show me which of them have the most errors, or show me which of them, give me the 90th percentile of all of them, and then show me which of the ones in the 90th percentile, have the longest running queries, or are using this particular query ID, or, you can just chain together all of these different questions to get to the answer, which is, the experience that I had many years ago where I was just like, I can't live without this tooling anymore. So Honeycomb, we've gotten to the place, we were really wandering in the wilderness for the first 3 or 4 years because it was so different from what people had heard about. And it takes some, I wouldn't say it's harder. It's actually a lot easier than using older tools because frankly the older tools were terrible and they were hard to use, and it's a lot easier to use if you can just ask the question you want to ask and just like do what you want to do. But it does require a bit of a mental model and a mental shift, and it took a few years for that to really click with people, but now we're growing really rapidly. We've got an amazing team of engineers, product people, designers. One of the things that I'm really most happy about and proudest of is just that Christine and I are not 22-year-old founders. We've been around the block a few times. We've lived through startups that broke our hearts, and I feel like it's been really important to us to create a company where we don't make the same old mistakes. And that means one of the things that we feel really, really strongly about is that engineers are not better than everyone else. In a lot of Silicon Valleys, you'll get this sense that like the engineers are the only people that matter. And right from the beginning, like we took the tack that we wouldn't hire anybody in the interview who talked shit about sales or marketing, or who act like those roles weren't just as important as theirs. And that's a lie that we will stick to, because it doesn't matter how great the software that you write is if nobody can find it, if nobody could buy it, if nobody can use it, right? All of the parts of the elephant matter. So,
Well, I have to say that in my, younger years, I used to have this misconception about.
oh, me too. I was a total snob.
I mean, I came from after my second job as embedded programmer. I felt like I was so much here than the rest of them, because I was doing C programming, so low level, so smart. But then after I mean, and even when creating a startup, you start to realize, and engineers can do things, but if they're not guided and if they're misguided, and with our first customers, it was not about the how reliable your product is. It was not about that, because if you're not ashamed when you release your product, then it's too late. You have to go, you have to test it, you have to see that it brings value. And if you're not using your product with the bugs, without the bugs, then it's a problem, because then you're not solving a problem then you already that you had. So I feel that there is a bit of I think it's about education, really. I think that technical people, engineers, don't realize how much how much their salary depends on the sales team, on the marketing team, on SDRs, on
Yeah, it's like any function, when it's done well, it's invisible.
yeah, yeah, yeah. But that's with DevOps, right? That's with DevOps, a
Hmm.
system administrator. You don't know if they've done
You
their
don't
job,
know. Yep.
if you don't have a disaster and you see that
Yep.
disaster recovery mechanism go and start doing things, then you realize, oh, he's doing things.
Yep.
Okay, so now that we've shifted, and let's talk a bit about developers. So technology is changing. The problem of it works on my computers, it was half resolved by Docker, but then came microservices, and then you have 100 of them, so you're still drifting from the production state. We have much more. We have CI/CDs now. There are a lot of tools that you can use to ensure, and testing tools, but still, developers don't and release teams don't release on Friday. Why is that?
Because they don't have any confidence in their deploys, because they're so broken and so breaky, and they don't want to ruin their weekends, which I get. But the solution is not to go, okay, so we won't deploy anytime. You see, the solution is to, if it hurts, do it more, right? If it
Yeah.
hurts, do it more. Make it so that it's fast. Make it, if it takes you 4 hours to deploy your code, or even an hour or two, I get it. I get why you wouldn't want to do that very often. But if it takes 10 minutes and it happens automatically after every commit, right? Then
Mm-hmm.
pretty quickly you will have a deploy system that you can rely on, and the benefits to your company will the ripple effects like are almost too many to name, because what you really want as an engineer is you want to be able to treat production like a REPL, right? You need to be able, you want to have that delay be as slow as possible, so that you're basically like writing code and watching it run, right? And like, we're not quite there yet technically, but you could certainly get it, out within 15 minutes, and look at it, at least to some, you know, I'm making some sweeping statements. It does depend, right? What your industry is, what your stack is, but like there are plenty of very large companies who, larger than you would think, who have taken this to heart and who have the ability to get their code out into a live environment so the developers can watch it run in production within minutes. And, it can be done. It's just that we don't put our energy in it because we don't see it as valuable. But it's
Mm-hmm.
incredibly valuable, because those few minutes after you've written that code are the best time to
Mm-hmm.
find bugs, because your knowledge of it, when you've written the code, you understand why you did it, what you didn't do, what didn't work, what the functions are named, what the variables are named, what to look for, right? When you're writing your code, you should be thinking about, how am I going to understand if this is working or not? What should I look at? What instrumentation should I add? And then, you merge it, you look at it, and you ask yourself, is it doing what I expected it to do? Can I see my code run? And does anything else look weird? Right? And if you do that, if you have that feedback loop, you will find upwards of 80% of all problems that you'll ever deploy. And the
Mm-hmm.
cost of fighting and fixing those problems goes up exponentially from the moment that you write them. So anything you can do to, as you said earlier, shift that left, to make it so that,
Mm-hmm.
production is part of your development environment effectively, to make it so that you're only deploying your changes. Like, one of the
Mm-hmm.
biggest problems that people do is, because they're afraid of deploys, they slow down and they deploy less often. And they batch up
Yeah.
multiple people's changes and deploy them all together at once. And the slower you're going and the more changes you're batching together, the more guaranteed you are to break something when you finally do.
Yeah. 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 And it's horrible with the merging at the end of it. Been there, done that with release branches. Well, okay,
Oh,
let's push
God.
everything here, and then you're a day before releasing, and you know you have to release, and someone else puts something there, and it's not working, and you start have to.
That's why the whole model of the day before the release, you
Yeah.
have to merge before release, is just, it doesn't work. It causes so much breakage and pain and
Yeah.
problems.
Yeah, and frustration decreases productivity.
Hmm.
And this is one of the things that Banishal aims to do. Is first, we say that we want to decrease, want to make the feedback loop smaller. So which means that every time you do a change, you get to have an environment that is identical to the production, in the sense that production becomes part of your development environment, right?
Oh, I don't believe that any environment can ever be identical to production.
Of course, but if you're testing locally, it surely will not be if you do have cloud native
Yeah, but I feel
services.
like that's kind of a false promise. If you're like, I'm going to do, I think you have to get it into production. You can't say an
Sure.
environment is like production, because part of production is the user traffic.
Oh yeah, that's perfectly fine. I mean, I get. how the way I see it is, first you have to test it. You have to test it even if it is a replica of the production. First you have to do it and not test it locally, and test it with a bigger similarity than to production. And someone did ask me once what I consider to be an ideal CI/CD. And an ideal CI/CD for me is when developers can push code to production. If that code is wrong, then it will not run, or it will be immediately rollbacked if it has issues. And you've seen now with the shift that for testing that there are not as many businesses that have testing teams. They're going to automation tests, and they don't do anything manual, which means every time developers write anything, it gets tested automatically, and it gets deployed automatically into the production environment as soon as the tests end. What Bunny Shell wants to do is provide those environments in which developers can have the state to see only their single change being tested. And of course, if they are doing multiple releases, they can test them individually, and they can test them together, not on the local machine, not on a static instance that queues tests, but on what we call ephemeral environments. And I feel that observability and environments as a service come together very, very good. Because first, you allow with an environment, you create the state of the change,
Yeah.
which you can
Yeah, I
observe.
don't know. I mean, it depends. It depends. Like, I can see some value in that, but honestly, if every company has limited engineering cycles to invest, and I would definitely invest. I would definitely always recommend that they invest in getting the code into production fast before spending time futzing with other environments, even if they are, I you'll catch some marginal amount of extra bugs by deploying to a production-like environment, but most bugs you will never catch until they're in production. And so just getting
Yeah.
it there as quickly as possible is how I would recommend people.
Yeah, I totally agree with that. Traffic is one of the things that does matter, and there are more things. And one interesting type of, for example, in a canary deployment, one nice tweak was you don't put the new version alongside the containers or the instances that have run until then. No, you spawn them a old one and a new one in parallel, because it matters even the state, how much time has that container or old application has been running, because of course it matters. It's a different state.
Yeah,
So
uh,
well, I
sure.
guess we can't deploy everything in production without testing it at all, can we?
No, 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 sure. You absolutely have to test, yes.
Okay. Um, let's go a little bit forward, and
I think I'm losing my voice here a little bit.
oh, well, if you have something hot to
No,
drink.
I'll be okay.
Okay, perfect. So let's see about DevOps content. So you do have a podcast and you write a lot, and you said that right now you're finding it a little bit hard, but just because you've recently published. What do you think about the content that's currently on DevOps? Is it enough? Is it correctly directed, or is it just marketed a lot?
I don't know. I feel like the DevOps content. I don't know that I feel like, honestly, I feel like DevOps is a concept that is becoming less and less relevant, honestly, um, because I feel like it was a really necessary first step. Like, I feel like the original sin of engineering was when we divided Dev and Ops in the first place, because that was just it was just a bad idea. It was a terrible idea. I understand why we tried it, because we were having trouble scaling ourselves, and it seemed plausible that this might be a way that it could work. It was terrible. We should never have separated them, right? Operating your code is indivisible
Yeah.
from developing your code. Um, and there was a big schism there that it took many years to kind of go, okay, this was a bad idea. Let's knit them back together. But the idea of like having dev and ops working really closely together is, I think, kind of an archaic one that just it arises from like healing that split. Like, I think that what we're starting to see is that is that companies are hiring engineers to write and ship code. Some of those engineers will be infrastructure engineers who write and ship infrastructure code. Some of them will be product engineers who write and ship product code. And there will always be like subject matter experts, like subject matter experts in, QA, subject matter experts in SRE, subject matter experts in like database engineering. But for the most part, I think we're just moving to a very generalist engineer who writes and ships and owns their code in production.
And as a leader, what are the most important things in creating that kind of culture?
It depends. I mean, the answer to everything is it depends. Um, it depends on what you're trying to counteract for, what you're trying to optimize for. Respect is certainly one thing that you can't, if you're an engineer, if you're a software engineer and you think that writing code is superior to making code run and serve users, then, that's not going to work very well. If you're an engineer who thinks that you're superior to all the other, fields, it isn't going to work very well. I think that creating a culture where no job is seen as too trivial of respect is big. I don't know. Is there something you have in mind?
No, I mean respect is one thing that I totally agree. Another one is responsibility for all the individuals. And I did like what you said. And no task is too little. I mean, I think that and. It's okay to be hands-on. It's okay. I mean, no matter the position. Of course, delegating is really important, but you don't. I mean, if you have, if there is someone that you can help and it's quicker for you to do it, you should do it. Doesn't really matter if it's just, if it's a QA or an engineer and you're in a leadership position or even with management position. And I also think that I also adore is, and especially in a company that is providing a technical solution. I've done some, I don't know if my team did like them. I've done some meetings with all the team in which we shared some technical knowledge throughout the company, both the sales team and the marketing team. One time we even had a Kubernetes hackathon in which we all of the company wrote a bit of Kubernetes there, so everybody knows what we're doing, in fact. And what about some indicators of a high performing team?
Well, I think high-performing teams have a very short time to deployment, like 15 minutes or less, ideally. I think that high-performing teams are ones that have good observability so they can tell what's going on. I think high-performing teams are ones that are not exhausted or overworked.
Yeah.
I think high-performing teams are ones that have a spread of levels so that, people get a chance to mentor and teach. And you don't just have a bunch of super senior engineers all kind of stuffed in there, all doing stuff that's boring to them half the time. I think that high-performing teams are ones that take things like reliability seriously and developer tooling seriously because, you're constantly subject to entropy and things are getting harder and slower and you're accumulating responsibilities. So high-performing teams are ones that learn how to say no and how to deprecate and how to, do migrations and get rid of technical debt. They're the ones that know how to focus on what matters for the business and take the cues of what matters for technology from what matters for the business. Stuff like that.
Yeah. So let me just ask you one more question before let's try to start wrapping it up so you can go drink a warm tea.
Yeah.
Okay, so because I said it works on my computer and this problem is persistent, it still exists. So what do you think developers need to have? What do leaders need to do so we don't have to worry about it works on my computer? And thankfully, if we solve that, we also solve the Friday deployments. What do we have to do to get rid of it?
I do have a T-shirt on that says "Test and prod or live a lie." Usually the first thing I will tell people who are asking about this is put your developers on call because they should learn pretty quickly that production is all that matters.
Okay. Okay, and I wanted to ask what we should do now to make developers' life easier, but I guess that's some of the this is some a question that you already answered with
Yeah,
you. I mean, in if you make releases very fast at the beginning, it's gonna be uncomfortable, but later
yeah.
on, it's going to be much more.
It's the only way. Software speed is safety when it comes to software. Shipping lots of small changes, right, regularly, like a heartbeat, right? It should be as boring and as nothing burger as just like as regular and as predictable as a heartbeat. That's when software is safe.
And do you think that integrating observability more and more with development teams, do you think that there is some shifting, some change in their way that they code or they organize their application?
Absolutely. It changes the way you write and ship code for certain because developers are used to writing code like as though it's in a black box, right? It's just like you set it off and you wait to get alerted, you wait to get paged, you wait to see if it's okay, right? They haven't had the ability to just kind of like inspect and go, is it actually running? Is it doing what I expected it to do? Does anything look weird? We encounter customers all the time or people who are trying out Honeycomb, and it's like you lift up the corner of the carpet and all of the little bugs just go squirreling out because there are so many things wrong with your system right now that you have no idea about. You just don't even know they exist until you add the right instrumentation, observability, and something like, oh shit, oh crap, and a lot of times people will be like, stop rolling it out. We need to fix these bugs before we keep going. And it's like, they've always been there. Let's just get the rest of the observability rolled out because, once you can see it, it's so easy to fix it. And when you can't see it, you're reliant on waiting for users to report it and for it to get triaged and for people to figure it out and get it into like your bug, your bug list or whatever. And that's just, relying on users to tell you where your bugs are
Yeah.
is really terrible. And it means that, most people who encounter bugs are not going to tell you about them. They're just going to like, close the app or reload the page or move on or just be frustrated and never come back, right? You need to get ahead of that. You need to be finding them before your users are finding them. That means instrumentation and deploying quickly and observing your code through the lens of
Yeah,
instrumentation.
yeah. And I guess that a very good consequence of deploying more frequently is going to be that there is going to be much less technical depth if you do that rather than if you deploy infrequently. And especially in
Well,
startups. In startups, you write a lot of
it
code that.
depends. It depends on what you mean by technical debt, and not all technical debt is bad. Most technical debt is good. It's like you can take out, just like in the real world, you can take out debt to like to send yourself to college, like that's good debt, or you can take it out to like blow it on a super fast car when you live in the middle of nowhere,
Yeah,
or just to like take out debt for nothing.
yeah.
But like it is good to take. Anytime you write a line of code, you've taken on some technical debt, right? So it's all about taking on wise debt, and it's about paying that debt down when it no longer serves.
Yeah, yeah, and you've made a great point because you can go and pay, for a college that is good, and or for a diploma that is not going to serve you really. So, and I think that especially in startups, the quicker the code reaches production and you validate it with your users, the more that you are going to write valuable code and not code that you think is good. And that's especially for startup in which a lot of code is thrown away because you do a lot of POCs and POVs with things that are not don't have maybe the value that you thought you had. So
Yep.
so thank you very much, Charity. It was incredibly nice to talk to you. I learned a lot, and again, congratulations.
Thank you. It's nice to meet you.
Yeah, for your book, and I do recommend it. I think there is a lot of knowledge that people can get from it, especially in understanding why such a system is required in nowadays and in nowadays
Yeah.
applications.
Good. Thank you very much. It's
Thank
very
you.
nice to hear.
Thank you.